We point to algebra of functions on on what was that, Wednesday, and today's Friday. So we started that. So we're gonna continue and just wrap everything up in that section. And today we're gonna look at the difference quotients. So it looks scary. It looks like some big formula that you have to memorize, but you don't have to memorize this formula. We are going to give it to you. So it's always given to you. So that's a good thing. And when you look at it, it's just a fraction. And it has like pieces of inputs already embedded into the formula. So when I look at it, one of the inputs that I have is f of x plus h. And the second one is f of x. So we have been dealing with input and things into functions already. So this is just the same thing. It's nothing really new. We just need to just take this formula apart and try to, get our inputs to satisfy this difference quotient. So these are the two pieces that we will be dealing with. And h is just h. H is not a function. It is just like, yes, probably some distance from x to h. Is just, there's another point, but it's nothing that we really have to input into a function. I want to say hi, Professor. I don't know who that is, and let's see this in real life. You know what I'm gonna do? I'm gonna start with it like a simpler problem, like breaking it up, a piece of it, and then inputting that piece into the rest of the formula before I just give it to you and tackle. Hi, Fatima. So here we have let f of x equal 2x minus 5. So they give us the function f of x is equal to 2x minus 5. So for the first one here, find f of x plus h. And if you guys can turn your mic off because I'm getting some feedback. I think I can, but if you can turn your mic down for a second. So it says find f of x plus h. So we know that x plus h is an input. So that's my x. So I'm going to put that information, x plus h, back into the function. And we have already been doing this, but I don't think we ever use like an expression like x plus h or, two terms together, come together. So once I have my input, I'm going to put it in where x is. So I'm going to write x plus h. Now I can multiply the 2 by each term that's in parentheses. So I get 2x. 2 times is 2x. 2 times h is 2h. And then I have to tack on my minus 5. So once I have this piece, I can go to my part B and substitute that piece in for f of x plus h. Now I have to subtract. So it says minus f of x. So I just need my original output for my original function, and I want to write it in parentheses because this negative is affecting the entire expression 2x minus 5. So we want to make sure we write that quantity in parentheses. And it's going to be over h. So I want to fix up the top. So do some yard work up there. So I have 2x plus 2h minus 5. And now this negative is going to give me, it's going to multiply each term. So I get negative 2x. And the negative 5 is positive 5 all over h. So now at this point, do not start crossing anything out from the h. Don't cross out 2h and h. We have to simplify the top first. We have to do the top first, combine like terms or whatever. So when I start doing that, I see I have a positive 2x, negative 2x that can cancel out. And then I have a negative 5 and a positive 5 that also cancel out. So I'm left with 2h on the top and h in my denominator. Now at this point I can cancel because there's nothing being subtracted or added to the 2h that's on top. So I can cancel the h's out. Those dots over there, I can cancel those out. And then, I shouldn't say that on live. Then I have 2. So all this that we calculated gave me 2. So we just had everything in pieces. So we just did the x plus h first, and then we took that information and applied it to the difference quotient. So if you have any questions, let me know before I move on, because once I move the slide, it's going to erase it. So everyone's good, I hope. And if you have a question, just press the little raise your hand icon button, whatever that thing is called. So in this problem right here, it's not broken down in pieces. We have the function of x is equal to 2x minus 3, and they want us to simplify the difference quotient. So they just throw the quotient at us, and we have to figure it all out on our own, no baby steps. So I know I have 2 inputs. I have f of x plus h, and I have f of x. So I have 2 inputs. So the f of x always comes from the original function. So f of x is equal to 2x minus 3, so we don't have to worry about that. That's always a given part. But we have to concentrate on the x plus h. We have to put that information back into the function. So I'm replacing the x with the x plus h again. And then we just multiply the 2 by the x, and then I multiply the 2 by the h, and I multiply 2 times x, I get 2x. And then when I multiply 2 times h, I get h minus 3. Then I have the pieces to put back into my fraction. So let me do that. So I have 2x, so going back here, I need, this is my f of x plus h, so I need that part. So that's 2x plus 2h minus 3. And then my second part is the f of x, so minus the quantity of that. So you want to put the second part, the last part, in parentheses. And now I need to just fix it up, clean it up some. So let me see, 2x plus 2h minus 3 minus 2x plus 3. And then I need to see if I can cancel anything out. I'm going to write the denominator after I cancel everything out. So 2x, negative 2x cancel out, a negative 3 and a positive 3 cancel out. So now in my numerator, I have 2h over h. And now I can cancel out the h's because they get on my nerves, those holes. And then I shouldn't say that. 2 again. The answer is not always going to be 2. So I know that in the first problem I got 2, and then in this problem I have 2. But it's depending on the function that they give you, your answer is not always going to be 2. So I just want to make that clear. So just break when they want you to find and simplify the difference quotient. You just have to break it up into 2 pieces to get your input. One input is x plus h, and then second input is x, which is always coming from the original function. Any questions before I move on to another problem, another example of this? Okay, so let's see. Same again. So I'm doing a bunch of these because it's very important that you understand how to dissect. That's the right word. I'm not into biology. I'm a mathematician, but dissect this. You want to, I just want to make sure you know how to dissect this. Yeah, that's the correct word. We have f of x plus h, and then I have my f of x, which is always my original equation. So now I need to input x plus h into the formula, into the function. Now to do that, I see that my has to be squared. So I need to do some foiling real quick. Because sometimes students, what they do, they'll do x squared plus h squared, but you have to multiply the expression by itself. So it has to be 2 parentheses, 2 binomials. So then you just FOIL x squared plus 2xh plus h squared. So once you FOIL that, you get x squared plus 2xh plus h squared. I'm not going to go through the whole first times first, last time last, because you learned that. I get to it. Yeah, because when you multiply, I was just saying that like it's just the FOIL technique, like x times x gives me x squared, and then if you do the outer x times h which give you xh, and then the inner, you get another xh, which is going to be 2xh, because this is like a 1 here, and that's a 1 here, and so that's 2xh, and then the last is h times h, which gives me h squared. So now that piece of the puzzle, now I want to continue to write this in parentheses because that negative is affecting the whole expression. So now I need to change the sign of everything that's in parentheses. So now I get a negative x squared minus 2xh minus h squared. Now I just need to take this information, my f of x plus h, and my f of x, and put it back into the difference quotient. So I have 10 minus x squared minus 2xh minus h squared, excuse me, 10 minus x squared. And I always put the second part, the f of x, the output of the f of x, in parentheses. So that information always go into parentheses, and then now I get 10 minus x squared minus 2xh minus h squared minus 10 negative. Remember, this negative is going to affect everything that's in this parentheses. So now I have a negative 10 plus x squared. And I'm not going to write my denominator yet because I want to fix up the top. And anything that's like, I'm going to get those together. So 10 and negative 10 cancel out. A negative x squared cancel out. And then positive x squared cancel out with that. And then now I have negative 2xh minus x minus h squared, excuse me, over h. So now at this point, I can factor the top. So anyone knows what I can take out of the top in the denominator, I mean the numerator? H, yes. So I could take out an h. And I'm going to take out negative h because for some reason my negative 2xh is negative. I don't want a negative like poking out. So now if I take out a negative h, I get 2x plus h over h. And now I can cancel, I cannot cancel the h that's in parentheses, but the h that's outside is multiplying the parentheses. So I can cancel that h with the h that's in the denominator. And then I'm left with negative 2x minus, well, let me rewrite it as negative 2x plus h, and then I can just multiply everything in parentheses by that negative 2x minus h. And that's the final answer. So let that marinate for a minute. a lot going on. So a quick recap, we just broke up our two inputs, x plus h and x. We found f of x plus h by putting it into the function 10 minus x squared. So we replace the x, only the x with the x plus h, and then we square that, and we got x squared plus 2xh plus h squared. Since that minus is there, I had to change every sign. So this negative, I had to change every sign in parentheses, so to the opposite. And then we just put everything back in and simplified the tops and did some stuff to the bottom, and that's all she wrote with that. Thank you. You're welcome, Lauren. So now we're going to look at total cost, revenue, and profit. It sounds like, okay, oh God, we're doing some technical stuff, but it's just still just inputting numbers into a function. That's it. So it just look fancy and black and white, but it's the same thing we have been doing. We just combining some functions together. We input in, trying to get the output. So we have this total profit, and everything is going to be given to you, so you don't have to try to remember formulas or get tattoos posted on your arm, so you can remember what's going on. So total profit is defined as total revenue, R of X, minus total cost, C of X, and is given by the function P of X is equal to R of X minus C of X. Something I said was funny. So they give us what R of X is, and they give us what C of X is. So the first thing I want to look at is P of X. So they want me to find P of X. So we know that P of X, sound like tongue twisted. I sound like Dr. Seuss. It's like I'm getting all tongue tied trying to say all this P of X and R of X, C of X, green eggs and ham. P of X is equal to R of X minus C of X. So P of X So P of X is equal to R of X minus C of X. So now I don't stop here. That would be good, but I have some information that I have that's given to me. So they told me that R of X is negative 0.3x squared plus 60x. And then they told me that C of X is equal to 3x plus 10. So I'm just taking this information and replacing it back into the function to find P of X. So it's not that bad. It looks bad at first. So R of X is negative 3x squared plus 60x. And then minus, so this minus C of X. So everything is going to be in parentheses after that because we need to subtract the entire function, or the entire quantity. So now I have negative 0.3x squared plus 60x minus 3x minus 10. So once I get them together and break everything out of the parentheses, order of operations, whatever, now I just combine anything that's like. Well, let me see something. I'm going to erase that. So I have a positive 60x and a negative 3x. So that's positive 57x. And then I have minus 10. So R of x minus C of x is negative 0.3x squared plus 57x minus 10. So that's what actually P of x is. So when I subtract R of x and C of x, I get negative 0.3x squared plus 57x minus 10. I should have, I need a bigger board. So the second part, I want to find R of 10. So R of x is equal to negative 0.3x squared plus 60x. And now once I have that, I just need to replace my x's. Yeah, because I'm tired of them. They won't leave me alone. So everywhere I have an x, I'm gonna replace it with a 10. And now I need to simplify. So I need to do the parentheses first. So 10 squared is, what's 10 squared? Anybody know what 10 squared is? Wow, 100, yes. $100. So I could buy some more toilet paper. And then 60 times 10. Here's 1,000. No, 10 squared is not 1,000. But if you want to give me $1,000, I'll take it. And 60 times 10 is 600. So now we want to multiply 100 times 0.3, negative 0.3, and that's going to give me 30, negative 30 plus 600. Negative 30 plus 600 is 570. So now I need to find C of 10. So I need to erase the board. So make sure you jot this stuff down real quick. Make sure you have all of it. Because once I erase it, I have to erase the entire board. If Blackboard people are listening, you have to find a way that I can erase only certain parts. So C of 10 is equal to 3x plus 10. So my function C of x is equal to 3x plus 10. So now, oh well, I guess that's better. Everywhere I see x, placing it with 10. So only where x is, so x is now replaced with 10. And I want to multiply that. 3 times 10, I get 30 plus 10 is 40. Now I need to do P of 10. Now there's a couple ways to do P of 10 because we know that P of x is equal to R of x minus C of x. So I already did R of 10. R of 10 was 570 and C of 10 is 40. So that information I did already, so I can just take those two pieces and subtract and figure out that P of 10 is 530. Or if I like math like I do, I can do it the long way. Remember, P of X was what? Negative 0.3x squared plus 57x minus 10. So I can take the 10 from here given and put it back into P of X. So P of 10 can be the information that not here, and I just substitute 10 into it. And I get negative 30 plus 570 minus 10. A negative 30 and a negative 10 is negative 40 plus 570 is 530. So you come up with the same answer. I use the white marker to erase stuff now. So any questions on that? So you can just do R of 10 and then C of 10 and then get that information and find P of 10, unless we try to be tricky or someone try to be tricky and put some other number in here. Say they put 44 in there, and then we would have to use the information from P of that we got find in P of X. If that makes any sense, I don't know what I'm talking about. I do know what I'm talking about, but it sounds like a lot. So that's the conclusion of 2.2. So let me know if you have any questions, and I just want to jot down a problem to make sure you guys got everything that I did in 2.2. Let me see. And I just want I can use this. Let's see. I'm just going to do this extra problem from 2.2. I don't think I did it the other day. And then we're going to find f of g times 2. And then f of g of x. And the domain. So you can start writing it too. Oh well. So for the first one, f times g of x, remember we want to multiply everything that's after the function, everything after the equal sign. Oops. Here they give us a 2, so we can do f of 2 times g of 2. So we take everything that's after the equal sign and simplify. So if I put 2 in back in for f, I get 4 plus 3, which is 7. And then if I put that information, make this a 2, my bad. put 2 back in for my x and my g function, I get 2, radical 2 plus 2, which is 4. And then if I simplify that, I get 2. So now I can multiply my g is 7 times 2 is 14. So everything that's after the equal sign, I take that, put 2 in it, and then multiply. Now B has f times g of x. So we could have done that one first and then put the 2 back in, but it is what it is. So the example had it written like this. So f times g of x. So break it down, f of x times g of x. F of x is 2x plus 3. And g of x is the radical x plus 2. Now you cannot multiply an expression times a radical, so this would be my final answer. I just put it in parentheses. So the first part I just wrote in parentheses. You can just leave it like that, or you can just write 2x plus 3 radical x plus 2 if you like, because there's nothing you can do with that. So now it says find the domain of f times g. So to find the domain first, I should have maybe find the domain of the original functions first. So f of x, if I look at this f of x here, the domain of that is all real numbers. Because remember, it's not a fraction, it's not a radical. So if it's not a fraction or it's not a radical, it's all real numbers. Now for the g function, we have a square root, so we what's inside of the square root and have that greater than or equal to 0, and then solve. So x has to be greater than or equal to -2. So my domain would be, use a different color, bracket, -2, comma, infinity. So if they want to know the domain of f times g, f times g, get it out, f times g is 2x plus 3 times radical x plus 2. So we need, it has a radical in it, so the domain would just be, taking into account our real numbers, it would be -2, bracket -2, -2, comma, infinity. The domain of f times g has to be our real numbers. This pen is driving me crazy. All real numbers greater than or equal to -2, and then interval notation, you would write it like that. So any questions? So that's all I have, unless you have some things you want to work. No, maybe so. Let a sister know. And see at the bottom, once I finish, I have to drop the mic. Drop the mic, sis. I'm about to. When is the next exam coming? I don't have the syllabus in front of me, but everything is going to follow the syllabus. It should be coming up soon because we need Monday and Wednesday. We are doing 2.3, and after that, that's when we're going to have a test. You will be notified via Blackboard, email, and everything, so you will have all the information you need. So have a good weekend. This is all I have for you.